In this question, we are going to look at several different Lewis dot structures. So there are 4. So it asks us to draw the Lewis dot structure first, then the VSEPR, to name the base and molecular shape, to ask, is this polar? Then to ask about the hybridization of the central atom. So in this case, we are going to start with arsenic hydroxide. So the number of valence electrons is 5, plus 3 times 6 plus 3 times 1. And so that equals 26 valence electrons. And so in this case, this problem is probably a little bit more difficult. I'm actually going to zoom in to give ourselves a little bit more space. But we know arsenic is the central atom, and it's going to be connected to OH. So O connected to H, O connected to H, O connected to H. So this right here is, in fact, means that there are 3 of that molecule connected to the arsenic. So we've used 2, 4, 6, 8, 10, 12 of our 26. So let's give octet. So we've used 24 of our 26 electrons. So the last 2 will go on the arsenic. So the next questions are about arsenic. And so we need to draw the structure. So arsenic has a steric number of 4. So now we have an arsenic with this structure. And we really could have moved it over, but that's okay. So connected to 3 of these, we have an oxygen, and one of them has a lone pair. And on these oxygens, we're going to just go ahead and draw them as hydroxides instead of giving them 3D space, mostly because we ran out of space. So the base geometry is tetrahedral, and the shape is trigonal pyramidal. So in order to answer the following 2 questions about polarity and hybridization, for the arsenic oxygen bond, we want to actually look at the electronegativity values, and they are 2.0 for arsenic and 3.5 for oxygen, and this means that this bond is polar. So if we go back to our VSEPR structure, we have 3 bonds, and it turns out that because they are not equally distributed, this molecule is polar. So the hybridization of the arsenic is an sp3 hybridization because there are 4 things that need to be hybridized. So now let's look at our next one, which is BrO2 plus. So we have 7 plus 2 times 6 minus 1. So the minus 1 is to make this charge. So in this case, we're going to have 18 valence electrons. So we're going to start by putting our bromine in the center, connecting oxygens. Now we're going to give them octet. So now we have used 16. Now we have 18 electrons. And so we need to give bromine octet. So the way we're going to be able to do that is we are going to remove these 2 electrons from here and give a double bond. So now we need to look at formal charges. So bromine has 2, 4, 6, 8 electrons, as do both oxygens. So the formal charge for the one on the top is 6 minus half of 4, minus 4, so that's 0. For bromine, it's 7 minus half of 6 minus 2. So this is going to actually be a 2 plus. And this oxygen down here on the bottom is 6 minus half of 2 minus 6, and that equals negative 1. So in this case, everyone has octet, but we can also see that the bromine has a charge on it. So when we look at this, there are 3 things. We have a steric number of 3. So our bromine in the center is going to have things at 180 degrees. No, 120. So we're going to go ahead and put the 2 oxygens here and make sure to return octet where necessary. add our formal charges, and look at this. So the base shape here is trigonal planar. The shape is actually bent or angular. And so now we can look at the bromine-oxygen bond to see what the electronegativity values are. And so we know that the oxygen is 3.5 from the previous problem, and bromine is 2.8. So this differential is 0.7, so it is going to be polar in that direction. So based on the arrangement of these atoms, the answer is yes. So the last question in this is what is the hybridization? So if we look at the bromine, we need 3 equivalently charged, or 3 equivalent bonds. So that makes it an sp2 hybridized. So let's look at 2 more examples. So for ONCl, the N is underlined, so we know that's our central atom. So it's 6 plus 5 plus 7, and so that gives you 18 valence electrons. That's an 18, let's add that in. So we'll put our nitrogen in the center, connect everything, chlorine, oxygen, give everyone octet, so use 16, 18. Now we need to make a double bond. So I'm going to remove these 2 from the oxygen and give a double bond. So the reason I did that is because typically halide ions, so chlorine, bromine, etc., do not in fact create double bonds. So let's look at our formal charges for oxygen. 6 minus half of 4 minus 4 is 0. For nitrogen, it is 5 minus half of 6 minus 2. That's also 0. For chlorine, it is 7 minus half of 2 minus 6, which is 0. So these are all, in fact, 0. So from here, we can actually go in and see what our VSEPR structure is. And so nitrogen has a steric number of 3. So it looks like this. So we now have this structure, no formal charges. So we have a base just like the last one of trigonal planar. And the shape is going to be bent. So let's think about the polarity. So we have 2 different bonds. We have the NO bond and the NCl bond. So oxygen is 3.5, nitrogen is 3.0, and chlorine is 3.0. So this is a nonpolar bond. This has a slight polarity, and due to that, we see a slightly, but still yes, polarity. And the hybridization for this steric number 3 is also sp2. So our last one here is PCl5, where we have, the valence electrons are 5 plus 5 times 7, and so this is going to give us 40. We're going to put our phosphorus in the center, and we're going to add 5 things to it. That's a chlorine. So now I'm going to create octet for each and every one of these chlorines. And yes, it does take just a second. But once we do this, the formal charge for phosphorus is 5 minus, let's make that up, let's just go 5 minus half of 10 equals 0. And for chlorine, it is 7 minus half of 2 minus 6, also 0. So this is a steric number of 5, which makes it a trigonal bipyramidal base. So we're going to go ahead and add in our chlorines. And then every last lone pair electron goes here. So in this case, the base is trigonal bipyramid. And the shape is trigonal bipyramidal. So now, in order to ask about polarity, we have the PCl bond. So chlorine has an electronegativity of 3.0, phosphorus is 2.1. So this is a polar bond. However, the arrangement of the polar bonds means that they will all cancel out. So the one, I'm going to draw these, I'm going to zoom in on our VSEPR structure and draw them in red. So we have this bond, we have this bond. So those are going to cancel out. Then we have this bond, and this bond, and those three cancel out. So even though it is 5 quite polar bonds at electronegativity difference of 0.9, the answer is no based on the arrangement. And so the last question is about the hybridization, and so that is sp3d. So when we look at these, it's important that we go through all of the steps, and don't forget that polarity can only be determined by the arrangement of the bonds.